So, good day, ma'am. I am Kyla Marie M. Pakatang, and together with my group mates, we're going to tackle about hair and textile fibers. So, this is our table of content. It has introduction, scientific background, collection and preservation techniques, analytical techniques, role of forensic chemists and toxicologists, reported case studies, legal and ethical consideration, conclusion and references. So, introduction. Hair and textile fibers are among the most common forms of trace evidence encountered in criminal investigations. These tiny materials can be transferred easily through physical contact and often remain unnoticed by both victims and offenders. In forensic science, the study of hair and fiber plays a vital role in linking suspects, victims, and crime scenes by examining their physical and chemical characteristics under a microscope. Forensic experts can identify their type, origin, and possible source, providing critical clues in solving crimes. The relevance of hair and textile fiber analysis lies in its ability to connect individuals or objects through even the smallest traces. For instance, a single strand of hair or a tiny fiber fragment found in a suspect's clothing can suggest contact or presence at a crime scene. Through advanced techniques such as microscopic comparison, infrared spectroscopy, and DNA analysis of hair roots, forensic scientists can strengthen investigative findings and help establish association that might otherwise go undetected. The objective of this paper is to explore the significance of hair and textile fiber analysis in forensic science, focusing on their identification, classification, and evidential value in criminal cases. It also aims to highlight how modern analytical methods have improved the accuracy and reliability of trace evidence examination, reinforcing their importance in the pursuit of justice.
So, good afternoon everyone. My name is Marin Shehan Joyce Bilosdok. I am from B Scream 3D, and today we are here to tackle about the hair and textiles under scientific background. So, hair evidence. Hair is mainly composed of keratin, which is a protein rich in sulfur that provides strength and resistance to decay. Its structure includes the cuticle, cortex, and medulla, which differ among individuals and species. Chemically, hair can absorb and retain substances like drugs, toxins, and metals from the bloodstream, allowing forensic toxicologists to detect them using techniques such as JCMS, which is gas chromatography mass spectrometry. These biological and chemical traits make hair useful for identification and substance analysis. Next is the textile fiber evidence. Fiber may be natural, such as cotton, wool, silk, or synthetic, such as nylon and polyester. Natural fibers are biological in origin. Cotton is made of cellulose, while wool and silk are protein-based. These synthetic fibers are formed through polymerization of chemical compounds. Their unique structures and dye compositions are analyzed using microscopy and spectroscopy to match fibers from suspects or the crime scene. Next, we have its natural production and disposition. Hair is biological structure, is naturally produced by humans and animals, growing in cycles and eventually being shed or forcibly removed, leading to its presence at a crime scene. Textile fibers or threads are manufactured from natural or synthetic materials and become deposited when they snag on clothing, furniture, or other surfaces, a process which is known as fabric transfer. These events are involuntary and unintentional, creating a physical link between the source and the location. And next we have is forensic significance. Hair and fiber analysis provides powerful associative evidence connecting suspects, victims, and crime scenes. Microscopes and chemical analysis can determine the type of hair, human or animal, its body origin and color, and chemical composition. Similarly, fiber analysis can reveal the material, color, and structure which can be matched to specific clothing or items. This allows investigators to establish a link, limiting the number of potential suspects or confirming the location of a suspect relative to the crime scene. That would be all for my topic, and good day to you all.
So, good evening everyone. I am Earl Vincent Elocawa, base Creme 3D, and my topic is all about collection and preservation techniques. So, collection and preservation techniques is hair and textile fibers are discovered at the crime scene through visual examination and alternate light sources and collected using specialized tools like forceps, tape flips, or vacuums with filtered traps. Each piece of evidence is documented with photographs and description, then carefully placed into a separate paper containers such as a bindle or envelope, and sealed to prevent contamination and preserve the chain of custody. So, collection and preservation technique is all about kini siya pagkuha sa mga evidence and to make it documented and photographs. So, pictures, kung kuhan fingerprints, dapat na documentation, na ay photographs, and isulod ni siya sa place with separate container or like envelope. Ang kasagaran masulod sa envelope is kanang fingerprint. And this is and let's go to the discovery methods. So the first one is visual examination. Investigator meticulously search the scene, looking for hairs and fibers with the naked eye. So kani siya is para ni siya sa mga hairs like mga buhok, balibo. Muna siya gitawag og visual examination. And another one is magnifying glass. A magnifying glass can aid in locating and identifying trace evidence during the search. So kani for example is kanang in the crime scene like mapusilan and namanggi ug moabot sa mga like daghang mga sagbot, and so namanggi na mga gagmay nga mga evidence, so mogamit siya og magnifying glass. And the last one is alternate light source or ALS. In alternate light source is can enhance the visibility to trace evidence like fibers, making them easier to spot. So usa ni siya ka flashlight, but dili ni siya ingon og katong flashlight lang nga pwede maiwag bisag asa ni mong gamiton kani siya for trace evidence. And let's go to the collection methods. So the first one is hand picking for force. This is for visible hairs and fibers, clean forceps and used to carefully pick and transfer the evidence. So kuani siya katong mura og gamay ni siya like kuan para makuha like sa hair, gamay man kanang hair niya, kasagaran dili man gina sa mga kuan sa kamot, so na siya pangkuha na muna siya gingon og hand picking force. Then another one is vacuuming with a filtered trap is an effective method for collecting minute trace evidence such as hairs and fibers that might be missed by manual collection. So kani siya is vacuuming. So kani nadagan makita makitaan nga vacuum like kanang limpyo ta sa salog, but kani siya, it's a part, it is a vacuum that pangkuha ni siya sa mga evidence. So, let's go to the tape lifting. Specialized adhesive tapes are pressed onto a surface to lift and collect the evidence. So, kani is kanang sa fingerprint, like, for example, kanang makahawid og pusil, unya naka-pusil siya, and kanang pag kanang mag-trace ana, para makuha ang fingerprint is gamitan siya og tape lifting. And another one is combing. A comb or brush can be used to gather fibers from surface. So kani dili man gid makuha tanan, so muna mo butang o mogamit og brush. And let's go to the packaging and documentation. So separate containers. Each hair or fiber sample is placed its own clean, approximately sized paper container, such as paper bundle or envelope, to prevent mixing other evidence. So kani siya, muna to ang mga evidence itagsatag sa gitsag butang, dili siya pwede isagol. And another one, documentation. The location of our evidence is recorded and it is often photographed before being collected. So in the crime scene, dili na siya pwede kanang makuha siya, but kinahanglan siyang i-document, and a photograph ay i-collect. And sealing and labeling. The container is then sealed and labeled with a date, time, case number, and a brief description of our contents and where what was found. So kani sealing and labeling. So kani, for example, nakakuha ka og kutsilyo, imong ibutang dito sa paper nga asa unsang orasa nakuha, then unsa ang case number, and a brief description og asa pud siya nakitaan. And chain of custody. The chain of custody is important because it proves evidence integrity, ensuring it has been contaminated, tampered with or substituted, which are crucial for its admissibility and credibility in a court. A broken chain of custody can be lead being evidence ruled inadmissible, potentially weakening and even causing the admissal of case and allowing guilty parties to go free. So kani siya, importante gid og magkuha evidence is kanang kusog, kay kung dili naay posibilidad nga ang case mawala, then maputol, and napoy possible nga ikaw nga mipasakag kaso, ikaw po'y mabulayan. And that's all. Thank you.
Good day everyone, my name is Azzy Iwan. My report is all about analytical techniques. So, common laboratory methods for hair and fiber analysis include microscopy, which examine characteristics like color, texture, and cross-section, and spectroscopy, such as Fourier transform inferred to determine chemical composition and manufacture for synthetic fibers. DNA analysis can determine if hair is human and its origin, while microspectrophotometry analysis of fiber absorption, spectra for color comparison. Other methods include staining test and solubility test to differentiate fiber types. So microscopic comparison. Microscopic comparison distinguishes hair from textile fibers by their structure. When hair featuring a cuticle, medulla, and cortex, while fiber are uniform and lack this natural structure. Key features for hair identification include the medulla index and scale patterns, which vary differing between the uniform and more organized structure of synthetic fiber and the less organized appearance of natural fibers. So, physical characteristic. Microscopic examination reveals details about color. Visual color is compared between known and questioned samples. Structure. Details like medulla and cortex of hair can be analyzed to determine if it is human or animal. Texture. Differences in surface texture can be observed. Cross-section. The shape of the fiber cross-section is examined. Mitochondrial DNA analysis is widely used in forensic science to examine hair and textile fiber evidence, especially when nuclear DNA is unavailable in hair analysis, can be extracted from the shaft or rootless hair, allowing identification even when the sample is old or degraded because maternally inherited and found in large quantities per cell. It provides a reliable means to link a hair to a maternal lineage or exclude individuals as possible sources. Although textiles fibers generally do not contain DNA biological residues such as sweat skin cells, or body fluids left on fabric may yield suitable for analysis. This helps investigators connect to suspect, victim, or object to a crime scene through trace evidence. FTIR spectroscopy provides a molecular level characterization of hair and textile fibers, enabling their identification and discrimination by revealing their specific chemical structure, composition, and physical characteristics like polymer type, keratin structure, and presence of cellulose or other natural components. This non-destructive, rapid analysis is a powerful tool in forensic science for linking evidence to individuals or sources by comparing known and questioned samples. We have two different types of textile fibers. So number one is for textile fibers, identification and classification. FTIR can identify the specific type of polymer. Polyimide modacrylic cellulose in both synthetic and natural fibers. Discrimination and differences between different classes of fibers and can identify maximum of fibers such as cellulose and synthetic polymers. Modification evidence. The technique can distinguish between treated and untreated natural fibers and reveal modifications to fibers. Forensic value. FTIR helps classify fibers for forensic purposes, aiding linking them to scenes or sources. So for hair fibers, molecular structures, FTIR provides insight into the molecular structures of human hair, primarily keratin. Discriminations can discriminate between different sources of hair, animal versus human, different types of human hair, and between treated and untreated hair fibers. Forensic application is molecular information adds a new dimension to hair analysis in forensic investigation, complementing traditional microscopy and DNA analysis. That's all, and thank you.
Good day, ma'am. My report is all about role of forensic chemists and toxicologists. Analytical techniques. Forensic chemists and toxicologists analyze physical evidence like hair, textiles, and substances to link a crime. victim, or suspect using scientific methods like microscopy and chemical analysis. They interpret results by identifying the chemical makeup of samples and determining their origin or presence, which is then presented in court as expert testimony to help the jury understand the scientific data. Key challenges include the potential for evidence degradation, the need for rigorous documentation, and the pressure to maintain objectivity and integrity in their work. Forensic chemist's role. Fiber analysis examine textile fibers for characteristics like their type, natural, synthetic, mineral, color, and shape to determine their origin and potential connection to a suspect or victim. Hair analysis. Compare physical and chemical characteristics of hair found as seen to known suspect hair identification can help determine if hair is human or animal and can provide information on race, sex, and even hair treatments like dyes. Techniques. Use methods like microscopy to compare characteristics and Fourier transformation, infrared FTIR spectroscopy to analyze the chemical composition of fibers. Toxicologist role. Drug and toxin analysis specially analyze hair samples for the presence of drugs, poisons, or heavy metals to determine if and when a person was exposed to them. Biological sampling. Analyze biological samples which can include hair to identify and quantify substances like drugs or poisons. Case similarities and applications. Evidence to transfer in violent crimes. Hair and fibers are often transferred between the suspect, victim, and scene analysis can prove this physical contact, inclusion, or exclusion. The evidence gathered can help the investigators either include or exclude potential suspects from the investigation. Expert testimony. Both forensic chemists and toxicologists present their findings as expert witnesses in court to explain the significance of the scientific evidence. Role in courtroom. Testimony. Expert witnesses, forensic chemists, and toxicologists serve as expert witnesses in court, where they explain their findings to a non-scientific audience like a jury. Explaining evidence. They provide expert opinions based on their analysis, helping to establish facts and link evidence to a case, such as confirming that a fiber found on a suspect matches a carpet at the crime scene. Defending findings. Their role requires them to clearly and concisely communicate complex scientific data and defend their methods and conclusion against challenges from opposing counsel. Challenges and limitations. Chain of custody. A major challenge is maintaining a perfect chain of custody, as any mishandling or tampering can make evidence inadmissible in court. Evidence degradation. Some samples may degrade over time or be difficult to analyze without destroying them, limiting the amount of information that can be extracted. Objectivity. Forensic analysis must remain objective and avoid being influenced by external pressure, which requires a high degree of integrity and professionalism. Interpreting results. It can be difficult to interpret results conclusively, especially if there is a limited amount of evidence or if It is a common substance with no unique origin.
Hello, my name is Gabriel Joseph Silverajo, and this is the case studies that we selected because it is related to our topic, which is hair and textile fibers evidences. Win William case. The Win William case, known as the Atlanta child murders, involved the death of at least 28 African American children, teenagers, and young adults in Atlanta, Georgia between 1979 and in 1981. The murders caused widespread fear until Wayne Bertram Williams, a 23-year-old freelance photographer, became the main suspect. The key evidence in the case was hair and fiber evidences. Investigators found fibers from Williams' home, car, and dog that matched those discovered on several victims' bodies. These include green nylon, carpet fibers, yellow rayon fibers, and dog hairs consistent with those from William German Shepherd. The techniques used in the analysis include microscopic comparison, light microscopy, and chemical analysis, such as spectroscopy, to match the fibers and determine their composition and sources. Forensic professionals, including forensic chemists and trace evidence analysts, played a crucial role in examining and comparing these microscopic fibers and hairs. Their careful laboratory work established strong physical links between the victims and William environment. The expert also testified in court explaining how rare and distinctive the fibers were, which made it unlikely they came from anyone else's home or car. The outcome of the case was that Wayne Williams was convicted in 1982 for the murders of Nathaniel Cater and Jimmy Ray Payne, two of the adult victims. The forensic evidence, especially the fiber and hair analysis, was central to securing his conviction even without eyewitnesses to the crimes. This case became a landmark example of how trace evidence and forensic science can play a decisive role in identifying a suspect and achieving justice in complex criminal investigation.
Legal and ethical considerations. In the Wayne William case and similar investigations, legal admissibility of hair and textile evidence is guided by standards such as the Fryer and Dober rulings. Under the Frye standard, evidence is admissible if the scientific method used is generally accepted by the relevant scientific community. The Dober standard used in the most U.S. courts today is strict. It requires the expert testimony be based on reliable principles, valid methods, and scientific testing that can be replicated and peer-reviewed. In the case of hair and fiber analysis, this means the techniques used such as microscopy and spectroscopy must be scientifically validated and experts must demonstrate their methods' reliability and relevance to the case. Ethically, forensic professionals handling hair and textile evidence must avoid evidence mishandling, contamination, and bias. Mishandling can occur through poor collection, storage, or documentation, which can compromise the integrity of the samples. Expert bias when forensic analysts unconsciously favor one side. Often the prosecution can also lead to wrongful conclusions. Ethical practice demands that experts remain neutral, basing their interpretation solely on scientific findings rather than external pressures or expectations. Maintaining objectivity and scientific accuracy is essential to ensure justice. Forensic chemists and toxicologists must adhere to strict chain of custody protocols, use validated analytical methods, and clearly communicate both the strengths and limitations of their findings. They must also acknowledge uncertainties such as the non-uniqueness of fiber or hair matches to prevent overstating the evidence by upholding these legal and ethical standards. Forensic professionals help ensure that scientific evidence contributes fairly and reliably to the judicial process.
Good day, ma'am. Good day, everyone. This is my video report, the forensic. So my topic is the conclusion and recommendations. So conclusion. So in the conclusion of the report, the analysis of hair and textile evidence plays a crucial role in modern criminal investigations, as demonstrated in Wayne Williams' case. Forensic chemists and toxicologists use advanced scientific methods such as microscopy, spectroscopy, and chemical analysis to identify and compare samples, linking suspects, victims, and crime scenes. These professionals also serve as expert witnesses, ensuring that the evidence presented in the court is reliable, valid, and scientifically sound. The case of Wayne Williams highlighted how trace evidence, when properly analyzed and interpreted, can become a decisive factor in solving complex crimes and achieving justice. The importance of this topic lies in its contribution to uncovering truth through science. Hair and FBAR analysis helps investigators reconstruct events, establish connections, and includes false leads, strengthening the overall integrity of the criminal justice system. However, maintaining strict ethical and legal standards such as adhering to the deliberate and fair criteria is essential to preserve the credibility of the forensic findings. So that's all the conclusion. So we proceed to the recommendation. For future directions, it is recommended that forensic laboratories continue improving microscopic methods for FBAR identification. Regular training, accreditation, and peer review for forensic professionals should also be prioritized to minimize errors and bias. By combining scientific advancement with ethical integrity, forensic science will continue to enhance the accuracy and fairness of the criminal investigations. So that is all the recommendation, and thank you.